This is just a recap video of the days what we just did. So we had days 1 through 4, tree diagrams, counting principles, permutations, and permutations from a subset. This is just, again, you're going to be seeing examples of problems that you've probably already seen before. So if you feel confident with the problem I'm doing at hand, then feel free to skip to the next one. So the first one here is tree diagrams. So again, remember how when you're drawing out your tree diagram, you don't write out the full word, you just use the first letter or an abbreviation. So again, for our sandwich option, we have either ham or cheddar, not cheddar, or cheese. And then that's for our drink decision. I mean, our sandwich, well, talking is hard sometimes. For our sandwich decision, we had ham or cheese. Now for our drink decision, you can have milk, juice, or pop. And the same goes for if you were to choose a cheese sandwich. Milk, juice, or pop. Now, to write out our outcomes, remember how we kind of follow that line here? So we have ham and milk, ham, juice, ham, and pop. If we're going to follow these arrows here. And again, the same goes for the cheese sandwich. So we have cheese, then milk, cheese, then juice, and cheese, then pop. And then if you add all of those up, we have 6 different outcomes. That should be, I think that was the same example that we had from the day 1 notes. Now for day 2, the counting principle. Remember how you can multiply them by the number of choices within each decision? So we have for our drinks decision, we have an entree, and we have a dessert decision. Now within that drinks decision, we have 7 options or choices. You're going to multiply them across, remember? This is the counting principle. When you have the counting principle, you can multiply them across. For entrees, we have 10 different entrees to choose from. In dessert, we have 5. So you can multiply those across, and 7 times 10 is 70. 70 times 5 is 350. So your final answer would be 350. So that was day 2, the counting principle, knowing that I was just kind of skipping doing that whole tree diagram here and going straight to multiplying these across. Now for our permutations. Slide. Whoops. See these. Here we go. Now we're calculating permutations. So preschool has 7 children in class. How many ways can I line up at the door to go to lunch? Well, let's see. We're going to have 7 slots because there's 7 spots in that line because they have 7 children. So first, second, third, fourth, fifth, sixth. Oh, I forgot one. 7. Now, for that first spot, there's 7 choices for a kid to line up because there's 7 kids. And then for the second spot in line, since we've already assigned one person, there's 6 people left. And that's just going to carry through because when you assign a person, there's one less option as we move from the first, if we go from the first person in line to the last person in line. So that's just 7 factorial. And 7 factorial, let me type that in my calculator really quick. Well, that's a large number. It's 5,040. Again, you can type that into your calculator or on Desmo somewhere. Now, next question is, how many ways can you arrange the letters in the word race? So I'm going to put our different slots here instead of having us draw out each one. So we have 4 spots because there's 4 different slots and there's 4 letters. So and they're 4 unique, there's 4 different letters. That's the key for this here. So in our first, second, third, and fourth. So our first spot here, there's 4 letters, and since we haven't picked one, there's 4 spots there. And then the second one, we know there's one less option, and so on and so forth. So that's equivalent to 4 factorial. And 4 factorial, we know, is 24 because 4 times 3 is 12. 12 times 2 is 24, and 24 times 1 is just itself. So those are 2 answers for that. Those were just the permutation examples. But now for this last one here, we're doing permutations from a subset. Remember, we want to reason through these problems. Always reason through. And it's asking how many different ways can a class of 7 students elect a president, vice president, and treasurer. So first step, we're going to draw our slots. So here's a slot for president, slot for vice president, a slot for our treasurer. So we know that if there's 7 kids, we haven't picked anyone yet, so there's 7 possible people that could become president. Then if we've assigned a president, we know there's 6 people left to be vice president. And then it goes on for treasurer. If we've picked 2 people, 1 for president, 1 for VP, there's 5 people left out of that total of 7. So we know that's just 7 times 6 times 5, which is just 210. So there's 210 different ways to do this. And again, we can check it by plugging these numbers back into that equation. So that equation is n factorial over n minus r factorial. And in this specific problem, our n is our total, and our total is 7 because there's 7 kids in a class. So we go 7 factorial over 7 minus, and there's 3 different spots we're filling. 3. 7 factorial over 4 factorial, which gets you 7 minus 4. So we know we're only writing down the first 3 numbers in 7 factorial, which is equivalent to what we just did down here. And so it's going to give you that same answer, 210. Again, this was just a recap. This wasn't learning any new additional information. This was just going over what we had just learned the last couple days of class. There is a paper version that I want you to write. I want you guys to actually have like a pencil and paper. You can either print out the homework sheet. It's on Schoology. And once you've completed it, I want you to either scan it in, take a picture, or you can use Cami to do it and send it in. But I want you to submit it on Schoology. If you have any questions, feel free to email. Thank you.